Sensors are the most important tool when it comes to scientific measurement. They provide us with a description of physical perception and hence play the most crucial role in data collection and analysis. Sensor calibration is an integral part of our scientific endeavors as it provides us with the correct range and relation to compare our data against so that we can reliably predict the output and state of a system in the future. In this lab, we analyzed load cells and accelerometers and calibrated them to give an accurate result. By doing this calibration, we made sure that any future measurements taken via the sensors are reliable and trustworthy.
For the load cell calibration, we obtained the ADC value for 12 different masses, ranged from 0 to 1000 grams. We did this in order to find the relationship between the mass and the ADC values. After that, we obtained the ADC values for 3 different objects, in this case a phone, a watch, and a pair of AirPods. We did this in order to find the masses of these objects using the relationship we found from the 12 different masses. For the accelerometer calibration, we wanted to calibrate the x direction of the accelerometer, so we used 11 different angles to measure the ADC value for the acceleration in the x direction. We also recorded the acceleration in the x direction while holding the accelerometer's x direction parallel to a table, and we did this in order to measure the inertial acceleration in that direction. By measuring the ADC values for all these angles, we can obtain a relationship between the acceleration in the x direction and the ADC values. After that, using this relationship, we can find the acceleration for any ADC value.
Upon analyzing the log cell data, we see that the relationship between the mass and the ADC value is linear. The resulting trendline equation can be used to calculate mass for any given ADC value. In our analysis, we got the trendline equation as for log cell calibration, y is equals to 0.002x minus 16647, where y is mass and x is the corresponding ADC value. Going further to the accelerometer calibration, we can clearly analyze that we get an even distribution of data points that are fairly close to the trend line, thereby suggesting that the data collection part was accurate. The resulting trendline equation can be used to calculate acceleration for any given ADC value. In this accelerometer calibration, we get the trendline equation to be linear and is given as y is equals to minus 0.16436x plus 54.054696. As part of further data analysis, the following plot was generated using the trendline equation. For each sample number, an ADC value is associated with it, which is passed into the trendline equation to output the corresponding acceleration. The following plot represents acceleration as experienced by the accelerometer as we slide it across the table.